In this example, we're going to be going over synthetic division. Synthetic division is a process of dividing polynomials, specifically by a linear divisor. The divisor must be linear in order for synthetic division to work, but it's a process or an algorithm to divide a polynomial by a linear divisor. So it does have its limitations with the linear divisor, but is much quicker and a lot less writing than long division. Now, depending on where you learn synthetic division, the setup might look a little bit different, but they each have the key ideas, which I'm going to mention in a second. So the way I was taught synthetic division is I use a little bar like this. There's other ways of doing it, but yeah, that's the way I was taught, so that's the way I also teach it myself. Then out here, what we're dividing by goes the root. Not the actual expression we're dividing by, but the root that corresponds to it. And remember, roots are solutions when the equation is set equal to 0. So our factor or expression that we're dividing by is x minus 3. So the root is, if we set it equal to 0 and solve, it's x equal to 3. So the number that I'm going to place out in front is going to be the number 3. So I will place a 3 here because that is the root that corresponds to what I'm dividing by. Now, inside this little bracket, we have two rows. One row and two rows. The first row comes from the expression that is being divided. We take the coefficient with each of the terms, and just like with long division, if we're missing an exponent, we need to put placeholders for that power. So, first term is x to the third. So we have x to the third, x squared that we're going to need, x, and then no x. There we go. And normally I don't write this down, this stuff up at the top. I'm just doing that to emphasize for the first setup here. Now the coefficient with x to the third is 2, so I'll put 2 right here. The coefficient with x squared is negative 7. The coefficient with the x to the first power, well, there is no x to the first, so that is going to be 0, our placeholder. And the coefficient with x to the 0, or basically the constant term, is negative 4. Now, we will start the division. Division will proceed like follows. We'll drop the first term down, and then the process will be just 2 steps repeating over and over again. Those 2 steps will be to multiply, then to add. So what we're going to do is we are going to multiply what we're dividing by times the next number in this line on the bottom, and we'll place that under the next number inside the bracket. So we're going to do 3 times 2 and get 6. So that's the multiplying step. Then the adding step, negative 7 plus 6 is negative 1. Then we'll repeat. We'll multiply. 3 times negative 1 is negative 3. And then we'll add. 0 plus negative 3 is negative 3. Then we'll multiply. 3 times negative 3 is negative 9. And then we'll add. Negative 4 plus negative 9 is negative 13. Now we just have to write out the expression. When you do polynomial division, if you've seen the long division problems, then you might have already noticed that the resulting polynomial has a degree less than the original. Specifically, 1 less. If you subtract the exponents, dividing by an x to the first will give us an x squared. So that means the first term here will end up being our x squared term. The leading coefficient is still going to be the leading coefficient. So whenever I write out the expression, that first term is going to be 2x squared. The next term is going to be minus 1x, decreasing the exponent by 1 as we go. Then we'll have negative 3 without an exponent. And then this last term is actually the remainder. So we'll have a remainder of negative 13 over x minus 3. I wrote that out without thinking about it, but we could also write it as 2x squared minus 1x, or x, minus 3. And since our remainder is negative, you may see it as minus 13 over x minus 3, like so. And there you have it. On the next example, I'll clean up the little setup here, and I'll do it like what you might see in class. This was more just to emphasize all the individual steps that's going on. So the next example will be a little bit cleaner than this one here. Okay, in this example, we're going to do synthetic division to divide the polynomial 3x to the third minus 5x plus 10 by the factor, or the expression, x minus 1. So I'm going to again go through the process, and I'm going to have a little bit less hecticness. Last example, I had a lot of craziness going on because I wrote some extra stuff down. But out front, I need the root of what we're dividing by. So the root of x minus 1 would be x equals 1. Set it equal to 0 and solve. So I'm going to put 1 out here. Then along the top on the inside, we'll go our coefficients for each of the terms. So our first coefficient is 3 with the x to the third term. So 3x to the third. Next exponent will be x squared. We don't have any x squareds, so 0x squared. Then we have a minus 5x, which I don't actually put the x's. And then we have a positive 10. So there's a setup without all the extra stuff I wrote down and highlighted last time. Now to actually do the process, we'll drop the first number down, and then it's multiply, add, multiply, add. So 1 times 3 is 3, and then add straight down. 0 plus 3 is 3. And then we shall multiply. Trying to erase some of the extra lines. There we go. So multiply 1 times 3, which is 3. And then add straight down. Negative 5 plus 3 is negative 2. We'll multiply. 1 times negative 2 is negative 2. And then we'll add straight down. Negative 10 plus negative 2 is positive 8. Again, this particular problem started off as a cubic. So whenever I divide by a linear expression, the exponent is going to decrease by 1. So whenever I write out the answer, it's going to be 3x squared plus 3x minus 2, with that last number being our remainder. So plus 8 over our divisor was x minus 1. Okay, in this example, we're going to look at how the value of P of A, so how the value, if we plug in a number, is related to the remainder of P of x divided by the factor x minus A. And this will lead us to some of the key properties and stuff for this unit. So in part A here, we're supposed to use synthetic division to divide P of x divided by the factor x plus 5. So synthetic division, just setting it up. Synthetic division bar. Our factor we're dividing by is x plus 5. I shouldn't use the term factor because it may not be a factor. But we'll set it equal to 0 so we can find the root. And the root will be negative 5. So we'll place negative 5 on the outside. And then our coefficients with each of the terms. We have 1x to the third plus 10x squared plus 29x to the first and plus 24. In this particular problem, I did not need any placeholders. We'll drop our first term down, and then we'll go through the process repeating multiply, add, multiply, add. So negative 5 times the 1 gives me negative 5. Then add going straight down. 10 plus 5 plus negative 5 is positive 5. We'll multiply again. Negative 5 times positive 5 is negative 25. And then add going straight down. 29 plus negative 5 is, plus negative 25 is 4. And then one last time, multiply. Negative 5 times 4 is negative 20. And then add to get positive 4. So we are supposed to specifically compare the remainder. So that's what we're going to do, looking at the remainder. So the remainder, again, is that last number when using synthetic division. So the remainder is 4. Well, I'm going to drop down and let's find P of 5, and then we'll compare the two. So P of 5, or P of negative 5, means replacing x with negative 5. And I did not, oh, there, I kind of have it in a horrible spot, so I'm just going to do it right here. I forgot that my screen cuts it out just a little bit. So P of negative 5, which I do want to point out is the same thing as what the root is. There is the same number there. But what that means is we're going to replace x with negative 5. So we're going to have negative 5 to the third plus 10 times negative 5 squared plus 29 times negative 5 plus 24. So we can do this in a few different ways. We can do it by hand, or we can type it in a calculator if it does order of operations for us. And I believe I have Desmos somewhere on here. Yep, there we are. So let's pull up Desmos here. Pop-up view, and okay, there we go. Forgot to get that ready ahead of time. But if I type this in so that we can clearly see what the remainder is. Negative 5 to the third power plus 10 times negative 5 squared plus 29. Oops, I placed that in the wrong spot. Squared. And then we got plus 29 times negative 5 times negative 5, and then we got plus 24. So after typing it into a calculator that does order of operations for me, I get that P of negative 5 is 4. Now, we were supposed to compare that to the remainder, and if you look, the remainder, using synthetic division, is also 4. So this brings us to two properties, and this will always be true so long as you don't make a mistake in the operations. It will always be true for every polynomial and everything you divide by, specifically linear factors, mind you. But that does bring us to a nice property. It also brings me to just pointing this out. It can be very hard to do this without a calculator depending on what the numbers are, which is why I just typed it in. I could have done a lot of it myself, but it probably would have been a pain in the long run and run a higher chance of a mistake. But synthetic division I can easily do without a calculator. So for tests like SAT, it can be very helpful if you know how to do synthetic division and save you a lot of time, especially since SAT is a timed test. If you have to find P of negative 5, you could just do synthetic division instead. It'd be a lot quicker. But with that being said, let's go down and take a look at the two properties. Two properties that we end up getting out of this, which we'll discuss for the rest of the unit, is the remainder theorem, which just states that if P of x is divided by x minus a, the remainder will be the same thing as P of a. That was the value of 4 that we found in the example that we just looked at. And the other one is an extension of this that says that is the factor theorem, which states that the expression x minus a is a factor of the polynomial if and only if the remainder is 0, which should make sense because a factor is a number that divides it evenly. For example, in normal numbers, the number 24, well, 6 is a factor of 24 because it goes in evenly without a remainder. 24 divided by 6 is exactly 4. However, 24 divided by 5 is 4 with a remainder of 4. The remainder means it's not a factor. So just like with regular numbers, if a polynomial goes in evenly and has no remainder, or a remainder of 0, which means if you plug the root in and you get 0 out, then it is a factor of the polynomial.